In this example, we're being asked to figure out the value of V naught here across that 2 kilo ohm using Thevenin equivalent. The way I interpret it is we need to deal with this 2K as a load, and the rest of the circuit, which I'll highlight here, the rest of the circuit, this one here, I'll deal with it as the Thevenin. So basically I'll find the Thevenin equivalent for the highlighted circuit and I'll connect the 2 kilo ohms in. So in short, what I'm asking you to do is to do the following. Figure out the Thevenin equivalent, okay, so that's V Thevenin and R Thevenin, and then once you do, you connect a load to it, and that load will be about 2 kilo ohms, exactly 2 kilo ohms, okay? So let's get started with that. So first we're going to figure out the V Thevenin, but of course if we need to do that, we need to remove this before I forget, because we don't need this anymore, or it's part of the load. Okay, so that leaves us with a V open circuit, which is from here to here. All right, well, based on this loop in here, let me just highlight it. Okay, if I highlight this loop, of course you can do nodal analysis, mesh, whichever you prefer, but we can also use KVL on this particular loop. This maybe you don't see it as a loop yet, but you can actually close this loop in here, and that loop actually incorporate the V naught. Okay, so if you write a loop here, you will get that, and I can just basically say this is here, plus minus, and that will be V1, okay, and I know the 12 volts. So that will be, if I get a loop like this, that will be negative V naught plus V1 plus 12 equals 0. That means V naught is just simply V1 plus 12. But what's the value of V1? Well, this current source in here will only go that way because there's no circuit in here. So that becomes just simply 2 times 1, which is 2 volts. So that is 2 plus 12, which is just simply 14 volts. Okay, so the V naught is 14 volts, and that is actually the value of the V Thevenin. So figure out the value of V Thevenin. So now next, what we need to do is we need to figure out the value of the R Thevenin. So we have different methods as usual. Okay, so out of these methods, we can choose whichever you want. I think as an initial method, or the first method will probably be the easiest in this particular example, and the reason why is because all the sources are independent. So I'm going to turn off that 2 milliamp. I'm going to turn off this particular voltage in here, but of course if I turn off a voltage source, I have to replace it with a wire, and then R Thevenin becomes the equivalent in here. So that's R Thevenin. Okay, and R Thevenin is simply, well, 2 kilo ohm in series, that becomes a 3, but it's on parallel with a wire, so they pretty much do not exist. So I can just remove them, they don't exist in here. Okay, so that tells me that the R Thevenin is just simply just 1 kilo ohms. All right, so that here is just 1 kilo ohms. So now I can take this circuit, which is the Thevenin equivalent, connect to it the 2 kilo ohms, and actually do the calculation and figure out what the V naught is. Okay, so let me just do this here, and that is V naught will be simply its voltage division, because that's the V naught in here. It will be the source, which is 14 times 2 divided by 2 plus 1, okay, and that should be equal to 28 divided by 3, or simply 9.33333 volts.